So basically, what is electromotive force or EMF? It is how much energy dissipated by the source in moving or driving a charge through a circuit, or how much energy one charge or 1 coulomb of a charge carry when chemical energy changes to electrical energy. So example, and how we can calculate this, say you have a battery. This is a battery. This battery can supply 100 joules of energy, and the number of the charges which are coming out from the battery, the total number of the charges which are coming out from the battery are 4. So how much energy 1 coulomb of a charge, this each circle is representing 1 coulomb of a charge. So how much energy carried by 1 coulomb of a charge when chemical energy changes to electrical energy, we call that as electromotive force, or you can say EMF. In short, you can say EMF or electromotive force. So example, I have 4 charges coming out from the battery, and the battery, the total energy, this is the total energy which is supplied by the battery. So how much energy each charge is carrying here? What is the energy carried by one charge? That's equal to 25. So 100 is the total energy divided by total number of the charges. So that's equal to 25 joules per coulomb. So if we want to calculate the electromotive force or EMF, is equals to total energy divided by total number of the charges. So total energy is, the total energy is 100, which is supplied by the hair cell, and the total number of the charges which are moving through the circuit are equal to 4. So each charge carry 25 joules. So 25 joule, 25, 25, total will be 100, but each charge carry 25. Then if one charge, if I say this is charge A, charge B, charge C, charge D. So before entering, the charge A will have 25. When it passes through, it will have 25 joule. When it passes through, it will transfer all of its energy so that the device or the component can work. So that the device or the component can work, so it will have 0 joules. So how much energy transfer by one coulomb of a charge that is known as PD, or potential difference. So how much energy transfer by 1 coulomb of a charge? It's not by all the charges, it's by only 1 coulomb. So that is known as PD, or potential difference. So what is the PD here? How much energy transfer by one charge? Like charge A, when it passes through the lamp, it was having 25, then it becomes 0. So the total energy which the charge transfer is equals to 25 joules per coulomb. And this joules per coulomb is also known as volts or voltage. Voltage is a quantity, volts is a unit. So in exam, you can write joules per coulomb, you can write volts. Both are correct. So basically, the concept of the voltage is energy which the charge have. If the charge get energy because of chemical reaction, we call EMF. If the charge transfer energy, If the charge transfer energy when it passes through a component, we call that as potential difference or PD. And both have the same formula. If we want to calculate a potential difference, PD is also equal to energy divided by the total energy divided by the number of the charge which are moving. So we can write voltage, which can be EMF or potential. It is energy or work done divided by charge. So this is a formula which relate energy or work done with charge and voltage, where V is the voltage, W is the energy or work done, and Q is the charge. Is it clear, the concept of the voltage and how the voltage is different from current? Basically, current is a movement of the charge. Like example, if this spotlight is representing a charge, so this movement of the charge is called current. But how much energy, like example, here the charge is having more energy. When it passes through, it will have less energy. The energy transfer or energy carried by the charge, that is known as EMF or potential difference. Is it clear? Any question related to EMF and potential difference? There is a difference between EMF and potential. What is the difference between EMF? EMF means when the charge get energy because of chemical reaction, the charge, how much energy one charge get, we call that as EMF. And how much energy one charge transfer, we call potential difference. The total EMF of the battery will always be equal to total potential difference. Here we are taking only one component, but for example, if we were having if we are having two components, say two lamps are there, when the charges flow through the component, the last component of the circuit, they transfer all of their energy to that component. Example, this is the circuit. On the battery, it is written 10V. If it is written 10V, what is the meaning of 10V? 10 volts. So what does it mean? It means if there is a 1 coulomb of a charge, if there is one charge, this pink spot is representing a charge, 1 coulomb charge, how much energy it carry? It can carry, it's 10 joule, not per charge, it is per coulomb. Yeah, 10 joule of energy carried by 1 coulomb of a charge. So this charge start to flow. Now my question is, what is EMF here? Electromotive force, energy which the charge get due to a chemical reaction in the battery or the cell. So EMF is equals to 10V. So EMF is equals to 10V. Now, example, this charge before entering, it was having a 10. The voltage, the energy divide between the component depending on the another property which is called resistance. If the identical components are there, so same amount of energy will transfer. If different components are there, different amount of energy will transfer. Like example, here the charge was having a 10 joule, but when it passes through lamp 1, this one is lamp 1 and this one is lamp 2. It is 10 joule. When it passes through this lamp 1, It is having 3 joules now left. How much energy is transferred by this charge across lamp 1? How much energy is transferred by the charge when it passes? So it transfers 7 joule. And so energy transferred by the charge is known as potential difference. Is known as, so what is the potential difference here? How much energy transfer? So a charge transfer 7 joules per coulomb or 7 volts, because 1 coulomb of a charge transfers 3 joules of 7 joules of energy. When it passes through the second component, it will lose all of its energy. Now it is left with 0 joules. How much energy is transferred by the charge? So that's equal to 3. So 3 will be the potential difference. And the same charge will return without any energy to transfer, but energy to return back. Kinetic will be there, but it does not left with any sort of energy to transfer. So basically a charge enters the circuit which carry energy. When it passes through the component, it transfers its energy and return back. The movement of the charge is known as current. When the charge is having energy due to a chemical reaction, we call voltage or EMF. When the charge transfer energy passing through the components is known as voltage or potential difference. So voltage is a common term which can be used for both EMF and potential difference. Is it clear, the concept of voltage or the potential difference and EMF? The difference between them basically? Then voltage in circuits, basically, or potential difference in circuits. A circuit can be a series circuit. It can be a parallel circuit. Series means they have only one way to flow, and parallel means multiple ways to flow. So you have 2 lamps connected in series, and you have 2 lamps connected in parallel. And you have EMF, electromotive force, say 10 volts here. And in parallel also, I'm using the same 10 volt supply. A 10 volt supply. So EMF is 10. EMF means when one charge will come out, it will carry 10 joules of energy. Example, this charge, when it enter, it will have 10 joules. Before entering, so before entering, it is having 10 joules of energy, but After passing through, it left with 5, and after passing through lamp 2, it is having 0 joules of energy to transfer. So what is the potential difference here across lamp 1? What is the PD across L1? The voltage or the potential difference across lamp 1. So the voltage or the potential difference across lamp 1 is 5, because that is the energy which transferred by the charge. So 5. And what is the potential difference across lamp 2? That is also 5. So what we can say that the voltage in series circuit, the voltage will divide. So in series circuits, the voltage will divide between the components. So what is the total voltage? It will divide if we have another component. So voltage will further divide into smaller numbers. But in parallel circuit, what happened? Like example, if you have a 10-volt supply, so it means when there is one charge, it will carry 10 joules. Now, when the charge reach this point, when 1 coulomb of a charge reach this point, now what happened? This charge has two possibilities. Either it can take path 1 or it can take path 2. It cannot take two paths together. Only because it's a 1 coulomb of a charge, so either it can flow through the first branch or it can flow through the second branch. So what happened if I'm saying this is charge A and this charge A is passing through lamp 1. So as it is passing through lamp 1, the charge A, before passing it is having 10, but after passing through the component, it will transfer all of its energy. Why transfer all of its energy? Because this charge does not have any other component to pass through. It is the only component, because the charge will return to the negative terminal. So this is the only component which this charge has to pass through. So before entering, it will have 10 joules, the charge. Once it passes through the component lamp 1, it will transfer all of its energy. And why transfer all of its energy? Because this charge does not have any other component to pass. So it will transfer all of its energy, and after passing it will have 0. So what is the voltage here? The voltage here will be 10, the potential difference. But what about lamp 2? How the lamp 2 will work? The lamp 2 cannot work with the same charge. So what happened? Then there will be another charge coming out from the battery, and that is charge B. And like charges are repelling each other. So if charge A follow path 1, the charge B will follow path 2. And charge B will also carry the same amount of energy, because every 10 volt means every joule, every coulomb is carrying a 10 joules of energy. So if charge A carry 10 joule, the charge B will also carry 10 joule, because the EMF means how much energy carried by 1 coulomb of a charge. So if charge A flow through lamp 1, the charge B will flow through lamp 2. And you can see a charge B before entering, it will have 10. And after passing, it does not have any other component to pass. It will pass and return back to the battery. So both charge A and B will transfer all of their energy when passing through the component, one component. So if it is 10 here, this will be 0. So how much energy transfer? It transferred 10 volts or 10 joules per coulomb. So you can see in parallel circuit, the voltage is same across each component within the circuit. Is it clear? Because what happened in parallel, there are two passage or two paths available for the charges to flow. So when first charge will enter the circuit, it can all follow path 1. Like if I say this is path 1 and this is path 2, so it can either follow path 1 or path 2. So if charge A follow path 1, then the charge B should follow path 2, and then they return back and transfer all of their energy in one component. So if they transfer all of energy in the one component, it means the EMF, it will be same as the potential difference. So in parallel circuits, the voltage will be same. In series circuits, the voltage will divide between the components. Is it clear? Uh, Regarding the working of the lamps, because this happened in a very short time, like nano of a second, so you don't find the difference that maybe lamp 1 is working first and lamp 2. It's a very small time interval that with our eye it appeared that both are working together or switch on together. But yes, there will be a difference. There will be a difference in a time interval, but that difference we cannot detect because that's a very short time interval. Is it clear to everyone? The series and the parallel circuits. If you compare the brightness of the lamps, in which circuit the lamp will be brighter? If identical lamps are I'm using, like here I'm using the same lamps, first they're connected in series, then they're connected in parallel. Which circuit you think the lamp will be brighter? Brightness of the lamp depends on how much energy received by the lamp, because energy is actually converted into. So in parallel, why? Because the lamps are having a higher potential difference or more energy transfer by 1 coulomb of a charge. But you may have a circuit which is a combination of series and parallel. So a circuit which is having a combination of series and parallel. So what happened? This is a circuit which is a combination of series and parallel. So positive and negative. The charges, I will draw two charges because there's a parallel combination. So one coulomb of a charge cannot flow through each branch. So example, if this was a 20-volt supply, 20-volt means energy carried by 1 coulomb of a charge. The size of the charge should be same. Maybe it appeared to be different, but it should be same here. So if you have two charges A and B, how much energy carried by charge A? The EMF is equals to 20 volts. How much energy carried by charge A? So that's equal to 20. So charge A carry 20 and charge B also carry 20, because electromotive force means it is a how much energy carried by 1 coulomb of a charge. So when the charge A and charge B enter, so they will not transfer all of their energy. Why they will not transfer all of their energy? Because they have to pass through other component. So example, charge A flow through this component. Just a minute, I will complete the figure and then use the numbers to explain the idea. Look, before entering, A was having 20 joules. Before entering, B was also having 20. But when it passes through lamp 1, A is having 15, say 10 joules of energy, and B is also having 10 joule of energy. What is the potential difference here? How much? What is the meaning of potential difference? Potential difference means energy transfer by one charge. So PD across L1. So that's equal to 10. Why it's 10? Because how much energy transfer by one charge, that is called potential difference. So PD or potential difference is 10 here. So A will have 10 joule, B will also have 10 joule, but when it passes through lamp 2 and lamp 3, A will transfer all of its energy and B will also transfer all of its energy, because there is no other component they have to pass through. So they transfer their energy and move or return back to the battery. So what will be the potential difference across L2? That will be 10. And what is the potential difference across L3? That is also 10. So basically what happened in parallel, we have the same voltage. Voltage across a component in parallel will be same, but this time it will not be same as the battery. Why this time it is not same as the battery? Because some of the energy is used in the component which was connected in series. So remaining energy is transferred to the parallel combination, but it will receive the same amount of voltage. So if this is in terms of charge, but if I simply draw this same circuit again in terms of voltage, just writing the voltages. So if this was a 20 volt supply and 10 volts was here, so remaining 10 will be across each L2 and L3. Is it clear? So even if there was another lamp, I connect another lamp L4 here. So what will be the voltage across that lamp? That lamp will also receive same 10 volts. Even I connect fourth lamp, that will also receive same 10 volt. So in parallel, the voltage is same between the component, where in series, the voltage will divide between the components. Is it clear? The concept of the voltage in the circuit? Yes, Mohsen, you have a question?
Yes, sir. For the charges to give their energy, like what's the factor that affects how much energy they transfer
There is a
or
resistance,
lose?
that how much energy transfer by the charge depend on the property which is called a resistance. Like if a component is having a high resistance, so charges have to transfer greater amount of energy before passing to pass through that component. If the component is, it's like you can understand in terms of peak. Like example, if you're moving on the horizontal plane, okay, you're moving on the horizontal plane and suddenly the road is irregular, which is having peaks, different heights. Now, which one, to climb a peak or to pass through the peak, which one you need more energy, A or B? Like you was having 100 joule of energy, means you the maximum possible energy available to move is 100 joule, and you want to move from point 1 to point 2. So you have to consume your 100 joule of energy, where you will consume greater amount of energy.
At B.
At B, because it is having a greater height, so you have to do more work done against the gravity as well as moving through a height. So here you will consume 80 joules of energy, and here you example you consume 20 joule. Same thing happened for the charges. The amount of energy which the charges have to transfer to the component depending on the property which is known as resistance. And also it also depends on another quantity, which, like if there's a component or no. If there is no component, if there's only one component in the circuit, so charges will transfer all of their energy. But if there are multiple components in the circuit, then the charges will divide the energy in a sequence, so that where there's a high resistance or greater force to oppose their motion, so they use most of their energy across that component. Is it clear?
Sir, so if the first lamp had like,
Hmm.
it will not work unless it has like 20 volts.
If
Will there
okay,
any charges still have energy as they pass?
they will try to supply energy, but
Will they still have energy?
okay, you mean like what you mean to say, like example, this lamp is required 20 volts for normal working, that you mean? This
Yes.
lamp, yeah. So you mean this lamp required 20 volt, but you're only supplying 10 volts, or you're able to supply only 12. So there are two possibilities, that this lamp might work, but it will have a not a normal brightness, it will be dim. This is what happened. Like example, sometime if you connect a filament lamp, or so what you will find, if the voltage is decreasing, the brightness of the lamp decreases. So it will not be, it will be bright, it will light up, but it will not be brighter as compared to it receive the same rated voltage. So this lamp will not be brighter, but it will work, like it will be dim.
Yes.
Okay. Then if we want to measure the voltage, we use a device we call a voltmeter. A voltmeter is used to measure voltage, and it is always connected in parallel. Why it is connected in parallel? Because in parallel the voltage is same. So whenever we connect a voltmeter, we always connect voltmeter in parallel. So here I will if I want to measure a voltage of the battery, so how I will connect a voltmeter? So I will connect a voltmeter in parallel. Up or down does not make any difference. And the circuit symbol for voltmeter is a circle with letter V. And for ammeter is a circle with letter A. So this is a voltmeter. If I want to measure a voltage across lamp 1, so I'll connect a voltmeter parallel to lamp 1. And if I want to measure the voltage of lamp 2, so I'll connect a voltmeter in parallel to lamp 2. So voltmeter is always connected in parallel, where ammeter is connected in series. So if we just recall the idea, like the differences between the voltage and the current. Look, current, what is the definition of the current? It is flow of the charges. What is the concept of the voltage? Voltage is energy carried or energy transferred by the charges. If we want to calculate the current, current is equals to charge divided by time. If we want to calculate the voltage, so voltage is work done or energy divided by total number of the charges. The SI unit of the current is ampere. The SI unit of the current, it can be, voltage is volts, or you can denote by V, or you can also say joules per coulomb. Then the current in circuits, the current in the circuit should be it can be series circuit or it can be a parallel circuit. For series circuits, it will be same throughout the component. And in parallel circuit, it will divide between the component. And voltage in the circuit, in series circuits, it will divide between the component, and in parallel it will be same through the all components. Is it clear? The concept of the voltage and the current. Any doubt related to this part? The comparison of voltage and current and how we can use. We'll solve the circuit questions as well, but first thing you should have an idea. There is one more topic which is resistance that we'll discuss tomorrow. Any question related to the class today?